Hello and welcome to another video. We're going to still be talking about linear regression, a simple one. So we're going to focus on two variables, one independent and one is going to be the dependent variable. In this case, we're going to continue to talk about a quantity sold as the dependent variable. The story is really has to do with the fact that the quantity sold is being impacted by both the price and the advertising, but we're not going to be talking about multiple regression yet. I'm going to actually talk about quantity sold as always going to be, this is the dependent variable, of course, and this is going to be the independent variable, so this is going to be the x, and the quantity sold is going to be the y. Of course, this is the one that we could control, that the one we could change or seek or observe. And in reality, what we can get to see that the price is going to determine the quantity sold. I just want to remind you that in the concept of sloping, the slope is going to either be a positive slope or a negative slope. If the slope is negative, then it's going to be an inverse relationship. If the slope is positive, it's going to be a positive relationship. When the slope is a negative inverse, it's going to have one of them is going to increase, the other one is going to decrease. And that's basically what we mean by inverse relationship. Both of them are going to be at the different direction or opposing direction, different way of incrementation, decrementation. One is going to increment, the other is going to be decrement. So in this case, in order to see the regression between the quantity sold and the price, I'm only going to focus on those two only. One more time, only these two variables are going to be my concern for this run of the data analysis using the regression as the method, a statistical method. So I'm going to go ahead and apply the regression. There's plenty of those for us, never to get bored with playing with these. And the first thing that I wanted to go ahead and get the y input is going to be this one here, and the x input is going to be this one here. I'm going to leave the label, okay, and confidence level, I'm going to leave it by default at 95%, which means we are allowed 5% room. And the output, I'm going to go ahead and choose a specific cell rather, and here is going to be A11. And I want to go ahead and add the residual and residual plots also as well, because I'm going to explain those in this video. And here we go. So it's going to take a second. And that's the beauty of Excel. I'm not really concerned, one more time, about all the different formulas that we look and examine in statistical class. That's not my concern. My concern is to use the tool as in this class in order to come up with the answer, so we'll be able to make a decision very quickly as econometrist or as an economist or as a decision maker, like in any business environment. So let's take a look quickly at the R square. This is going to indicate there is some sort of correlation between the two. There's not a very strong, but it's not weak. So 0.65 isn't a good correlation, but it's not the best in the world. So I'm going to go ahead and leave it as celebrate the fact that I could continue to talk about this. So immediately I'm going to go to the significance of the F, and I'm going to see if this is going to be less than or less than 0.05. Remember, we talked about the 95% confidence. That's great. So we have a significance for the F. So we could continue to examine the result of the statistical analysis to see where is the coefficient. So we'll be able to form our own equation. Okay, so the coefficients is going to be the intercept, as we call it, beta 0. And this is going to be beta 1, which means the coefficient of the x. But before we do anything in relation to these, one more time, maybe this is a redundant video of the one that before that, we wanted to look at these two, and if any of these two values have less is not going to be less than 0.05, then we have to really drop this. In this case, we cannot, drop both of them because there will be no equation whatsoever. So if we ended up with these two are not less than one of them, we have to drop it because it doesn't make any sense to use that value into our equation if it's not less than 0.05. So as long as these two are okay, I guess both of them are okay, we could go ahead and check that. If let me go ahead and do that just for my peace of mind and also to take my time to slow down. If this is less than 0.5, keep it, meaning we have to keep that value. Other way, we're going to discard from the equation that we're going to discard from the equation. Of course, we're going to keep it. I could use the fill handle to go ahead and make sure that both of them, as a result, both of them are going to be valid. So what is my equation? What is the equation that I'm going to use in order to predict my future values? So the equation is going to be, this is basically, usually it's y associated with p0. I'm going to go ahead and put 0 here and make it extremely small as it is in the statistical books. So I could go ahead and put that into even smaller than that. I guess I know a trick that will allow me to do that smaller than this. Let's go ahead and see if we can put that 6, or maybe, yeah, it did do it. So this is basically this one here plus b. I'll go ahead and leave the 1, then I'll make and of course x is going to be, here we go, this is going to be, let's say size, the x is going to be size 12, and the b is going to be size 12 as well. So we could leave the beta 1 and beta 0. So this is the equation. And where is my beta? Actually, this is also, we call it the y hat, because this is the equation that we going to predict for the model. Okay, not the data that we observe. This is the prediction model through this equation. Anyway, this is going to be uh, b beta 0 is going to be this one here, plus this is going to be beta 1 and at any value. So let's assume that we have a price of, let's say 4.5. So what will happen is the quantity sold at price of $4.50, and that is going, okay, there is a mistake here. I forgot to add the asterisk. I'm thinking mathematically instead of following the rules of Excel. And this is what we will be able to sell. This is the quantity sold at the price of 4.5. If I go ahead and do this again with another price, let's say the price is 1.5. I already have it with, no, I don't have it with 1. The smallest one I have in 2. So if I have it here with 1, if this value increased as a result, which it should be, because there is an inverse relationship between the price and the value, which is the quantity sold. So as a result, this value, the quantity sold, will be increased as a result. So let's go ahead and do this. This is basically my intercept, y-intercept. This is going to be my the price, the coefficient of the price, and it's going to be, don't forget the asterisk this time. I'm reminding myself to go ahead and put 1, and notice how the quantity sold is going to be a lot larger at $1 price. So actually, this is interesting to see that at 1 and at 2 seems to have the same value. Let me go ahead and see that. No, at 2 actually we ended up having. So there is, this is yes, this is the prediction model at 2. This is the observed value at 2. So there is a difference between the two. How do we actually understand this even better? Let's go ahead and look at the residual output. I have problems pronouncing this word. So this is basically when we have the price at 1, what we have the observation, and let me see here where we have the observation when we have, yes. So in the observation, we have here, okay, we had $8,500 when we had in the observation 1 at price 2. And if I could go ahead and see the prediction at price 2, it's going to be this value. We already calculated this value when the price is 2 to be equal to the price of 2. So what is the residual is the point that how far or how distance is the value 7,676 from the observed value, which is the 8,500. So this is going to be calculated as follows. It's going to be 8,500 minus this value, okay? And you will notice this is going to be giving me those two values equal. But how did I obtain this value? This value is going to be the 8,500, which is the observed value, minus the predicted value through my equation. This is what Excel gave me in order to tell me how far is this one here from the actual value. So it is 823 points actually from the 8,500. So this one here. And the same thing here, if you take a look at this one, which is going to be 4,000, that's the observed value, 4,700 minus this one here, which is the calculated or predicted value. So this is going to be the same value, which is minus 500. So you probably guess how we're going to calculate everything in the residuals.